Hello, in this video we are going to cover a tiny bit of this blue PowerPoint, the red little orange picture by the way, and the other couple slides in this presentation that we missed, and the other one, as much of this presentation as possible, and these pictures. Okay, so to go through a few details with you. Okay, we have the lithosphere, which is the Earth's rocky part of the layer. So that's the land, the mountains, the Earth's crust. So if there's volcanoes or earthquakes, that's all part of the lithosphere. That's the rocky layer. Okay, the other layer is the hydrosphere. So that is the clouds, the rain, the oceans, rivers, glaciers. I'm not sure if I said that twice. Okay, and that's all water-based. Okay, hydro has to do with water. Atmos has to do with air. Okay, so and there's different layers of the atmosphere as well that we'll take a look at in a minute. And there's certain gases that our atmosphere is made up of more than other gases. And then the biosphere is the living things. Okay, the plants, the animals, the birds, the bugs. Okay, all the things that are living, living things. Okay, same thing, different picture, right? Trees, water, air, rocks. Okay, this atmosphere picture is a little confusing though because it has the clouds in it, right? So the clouds would actually be in the hydrosphere box. Okay, another picture if that helps you understand better. Atmosphere, hydrosphere, lithosphere, and then biosphere would be specifically the birds, the grass, the what's that, a sheep, cow, ducks. Okay, and but this arrow thing is mostly showing where living things tend to exist, right? Not many living things can fly super high, and not very many things live super deep in the Earth's crust. So those are the spheres of Earth. Okay, last one. Same thing, different words, different picture. Same thing, different picture. So if you were to label with an arrow, atmosphere, this blue, hydrosphere, this blue, biosphere, plant, lithosphere, Earth. See if you can guess what this one is. You're right, it's the composition of the Earth's atmosphere. So these are the types of gases in our atmosphere. A lot of people think that most of our air is oxygen, but it actually isn't. Most of the air we breathe is actually nitrogen. Luckily for us, nitrogen doesn't do anything. Okay, there's certain kinds of bacteria that can fix it for fertilizer for plants. So we use N-nitrogen fertilizer, right? But we can't breathe it. So one of the reasons climate change is such an issue is because, see this tiny little sliver that is carbon dioxide? The composition of the atmosphere is only 0.03%, I believe. So even if we change the carbon dioxide in the atmosphere by just a tiny little bit, that has a big impact on the planet. Okay, and then, oh, what's the joke? Oh, I would tell you a good chemistry joke, but all the good ones are gone. Get it? Are gone. Okay, and then there's other kinds of gases. So, oxygen in, carbon dioxide out for humans, and plants do the opposite. Okay, and just a fun fact, there didn't used to be any oxygen on the planet until the algae and plants were invented, so good job, phytoplankton. Okay, this one is about the layers of the Earth's atmosphere. Scientists like to divide up roughly where things are. So just like the electromagnetic spectrum, it's not exactly a hard line that says, okay, this is radio wave, this is microwave, this is infrared radiation. Same thing with the layers of the atmosphere. I forgot the E on ozone here. So these are separated by temperature. Okay, did you hear that? It's one of your quiz questions. These are separated by temperature. The layers of the atmosphere are separated by temperature. So if you see any of these words, troposphere, stratosphere, mesosphere, thermosphere, exosphere, those are all atmosphere words. Okay, exosphere is like closest to space. I think there was a guy in a Red Bull video that jumped from the edges of space, so he was like up here somewhere. and jumped into the big skydive. Thermosphere is like the last layer of heat, right? It starts getting quite cold after that. And the particles of air are much less dense out here, held in by the gravity of Earth. Okay, then there's mesosphere, which means middle. Stratosphere, I don't know what that means. Okay, but that's the highest some fancy planes can go into. And troposphere is where most people operate, right? Hot air balloons, birds, weather, airplanes. Okay, so that's the troposphere layer. Next one here. Okay, nobody understands this in grade 7, but it is a big concept. Okay, so I make sure and teach it for a long time because in grade 10 you need to learn it again. So let's have a look at what is going on. Here's the temperature in degrees Celsius, and this is what happens when you heat up water. So literally, as a fun experiment, I should go do it for you. Yeah, I should. You take some snow, which we don't have handy. We did this in the winter time, and we pulled this. We went and got a pail of snow out of the backyard in the classroom, and we put it in a beaker, put a thermometer in it on a hot plate, and melted it. So they recorded over time from -20 up to 0 how long it took. Okay, and this would be time in minutes, right? So it's not so much the time that we care about, it's where we see the changes of state, not like Texas, Alabama, okay, but like whether it goes from solid to liquid to gas. So first you start with ice or a freezy or a slushy, whatever you want, some kind of solid form of water, and then it takes time to melt. Okay, this is the flat part in a graph. It's called a phase change. So it takes time for all the Slurpee in your cup to melt into a liquid syrup. Okay, it takes time for snow, it takes time for ice, whatever we're working with, okay, to melt. So this flat part in the graph is showing that heat is still being absorbed by making that phase change happen, by melting all the ice, but the temperature does not go up. Okay, then you have another period of time where the liquid heats up, it heats up, it heats up. Okay, your Slurpee, your water, whatever you're working with. And then at 100 degrees Celsius, and this is at atmospheric pressure, standard atmospheric pressure, so like down by Vancouver. In Calgary, it's a little bit different, but you don't have to learn that. Okay, I'll just go back and teach grade 7 bit. So these temperatures are a little bit different depending on where you live, just fun fact. Okay, so what's going on here is at 100 degrees Celsius, that's key temperature. So 0, 100, kind of easy to remember. This is where all the water or Slurpee juice boils off. Okay, it takes time for all that water to evaporate into water vapor. Okay, so this would be the vapor phase. So if it was just regular ice, this would be ice, melting, 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 water, water, heating up, heating up, heating up, and boiling, 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 no water left, and now it's all a gas. The end of that. Okay, next detail here is we're going to focus on a Chinook. Okay, you basically have to know what a Chinook is, otherwise you can't live in Calgary. Just kidding. Okay, in Calgary we have these. Not everywhere does. So this is where it's -20 in the wintertime in January or February or March or whenever. And then all of a sudden there's a warm wind that just seems to come from nowhere. You'll notice it always comes from the west. So point to the mountains. Ready? Okay, point to the mountains. That is where the warm, dry air comes from. So we have the ocean over here. And it can probably happen in other places, but we know about it in Calgary. Very exciting. Okay, and so as I mentioned in a different video, the warm, moist air is going to go up over, trying to go over the top of the mountain, but as it gets colder up higher in the atmosphere, the energy is no longer there. So your water vapor molecules are going to condense and make a cloud, and it rains, right? So this is why the BC side has all the trees. My other video had the example of the Himalayas, right? This would be the rain shadow, okay? And this warm, dry air that comes On the other side of the mountains that has no moisture is our Chinook. Okay, so plus 10 added heat. It's cold here, right? Colder on our side. So it's like a wall. It's a wall cloud, not a real wall, but like a temperature. And then the wind blows that Chinook to town. Oops, needs some on it. There you go. Warm, dry air. Okay, makes it nice and warm for us in Calgary. And then the Chinook goes away and it's cold again. Okay, so here's an example of places where Chinooks are felt the most strongly. Apparently Lethbridge is warm for Chinooks. How interesting. Yeah, and sometimes if you look up at the sky, you see this like very sharp line in the clouds when there's a Chinook. So check it out next time you notice a Chinook happening. It's very cool. Okay, 4 minutes. Let's see how much I can get done in 4 minutes before my timer goes. This one was the last bit of one of the presentations. Okay, it has to do with the atmosphere. And convection currents is what makes the air move. Okay, so hot air at the equator is going to rise and becomes a high pressure. That's usually what they talk about in weather videos, right? If you've ever seen the news, I don't watch it a lot, but they say, and then we have an area of low pressure coming in from the Arctic, and that means we're getting cold weather, and it's more likely to snow, I believe. Okay, and I just know high pressure means hot out, low pressure means cold and like snowy. So that's what we get. And obviously it's very complex because there's also oceans involved, there's land, there's lakes that affect everything, whether it's sunny or windy, right, and how much solar radiation is, right? There's a whole PowerPoint on that, which is going to have to be in another video, but that's right. Okay, so lots of different reasons for temperature. So if you want to be a weatherman, you'll be very busy, weather person. Okay, so what's wind? Movement of air from an area of high pressure to low pressure. Yeah. Okay, so windy. And what's great about that is if it's really cold in one area, the warm air from a different area can flow and heat it up. Okay, so budget surplus means it's nice and warm. To budget deficit, so it's nice, it's cold, right? Depends whether you like it hot or cold. Okay, so air flows around, makes wind. Coriolis effect has to do with the air moving because the Earth is spinning. Okay, and apparently it goes to the right in the northern hemisphere, and in the southern hemisphere it spins to the left. Sorry, I don't know why. I think it's just a weather person thing to be interested in. Enjoy. Do I want to save that? No, I didn't make any changes. Okay, that's that one. I wonder if I could get through all of this in one go. Let's see. Let's see if we can do it in 2 minutes. Okay, let's mostly just look at the pictures. Okay, energy and the biosphere. Where does it come from? The sun. Through radiation, through space. Okay, what do we use it for? Photosynthesis and heating things up. This one we did in a different video. This is showing how radiant energy is distributed differently depending on where you are in the planet. Hotter in general in the middle, right? Australia, Sahara Desert, Brazil. Colder in Tuktoyaktuk, Russia, Antarctica. Okay, polar bears, penguins. Insolation, sol means sun. Okay, so we're going to have different amounts of radiation depending on the angle of the sun. Okay, in the sun, in the summer, is directly overhead and you can just feel it like beating down, right? And in the wintertime, it's less direct. They always use flashlights to help show this, right? Because if you shine a flashlight directly down, it's stronger, it's more intense. Whereas if you point it off to the side, it's more spread out, it's less intense. Okay, try it with your phone if you like. Okay, you have a little flashlight on your phone. Okay, another piece is the angle of inclination. Okay, the Earth is tilted towards or away from the sun. Okay, at spring and winter and summer and fall. So watch the seasons video to help you understand that a little better. Okay, so winter, our winter, we're away from the sun, so we get less radiation. And in the summer, our summer is different. Did you know that? From northern and southern hemisphere? Yeah, so when it's our winter, it's their summer. Very cool. Okay, albedo, there's a note on that. This is all about seasons. Okay, angle of incidence.